trained already. Mr. Park answers the question. Just stay silent. Well, you guys are well trained. Oh, your participation grade is going to go way down then. I know I don't have one, but if there was one, it would be way down. Now, can I assume you guys know the basics about probability? The probability, really, of an event occurring is always going to be a number between 0 and 1. If the probability is 0, what does that mean? It will not happen. If the probability is 1, it will happen. But most of the time, it's going to be somewhere in between there. Okay, so of course, we will start with the simplest case, tossing a coin, a fair coin. Now, if I don't say anything, you have to assume that it's fair. But later on in the problems, you're going to get coins that are not fair. Actually, some people actually believe coins are not fair now. Have you read that? That's because if you cut the coin in half, like this, exactly in half, it is a little more dense on one side than the other. Right? Because if you look at, I don't have any coins on me, but the heads and the tail. But for the most part, it's pretty darn close. Okay, so we're just going to assume it's equally likely to get a head and a tail. Okay, so if I toss a coin once, what's the probability of getting a tail? I'm just going to put T for tail, that's all I've said. Huh? 1/2. It's easy. But then later on, we're going to do problems where the probability of tossing a tail will be like 2/3 or something. You make one half of it really, really dense, maybe made out of, what's a dense metal? Lead. And the other side is like aluminum. So that's how you can make an unfair coin. Okay, but we're going to assume it's a fair coin. So isn't that pretty easy? But now, what about tossing 2 coins? So, see, when you do probability for the first time, is this the first time you're doing probability? When is the first time you learn probability? Again, now.
Pre-algebra.
You know, that's right then. And who was your teachers? Really?
I had Mr. Lebeau.
Monsieur Lebeau.
Mr. Lebeau.
And then what other teachers teach pre-algebra? Kowata? No? Okay, everybody had Monsieur Lebeau then. Okay, so when you first learn probability, what you want to do is write out all the possibilities. So what can happen when you toss a coin? You can get a head or a tail, right? There's only 2 possibilities, so that's why the denominator is 2. You want the probability of getting a tail, but there's only 1 of them here, so that's why it's 1 out of 2, right? But what happens when you toss 2 coins? How many possibilities are there? Well, let's write it out. And by the way, what do we call this when you write out all the possibilities? This is called the, do I have to make the hangman? 1, 2, 3. Okay, when you write out all, anybody here taking AP stats? What do you call it when you write out all the possibilities?
Sample space.
Oh my God. See, if those of you signed up for AP stats, you gotta remember these 2 chapters, right? I don't know how in depth does it go? Like, do they do really hard permutation combinations and probability problems?
Oh, we don't really do combinations and permutations.
Just but then don't you have to know permutations and combinations to do probability? Or you get the simple kind probability? Oh boy. Okay, at the very least, remember the probability then. Anyway, it's called the sample space. Tanaka already got it. It's a listing of all the possible outcomes. So if you can write out all the possible outcomes, probability is easy. But then lots of times, there's just too many of them to write out, so you gotta use combinatorics. Okay, so what happens when you toss 2 coins? What can happen when you get 2 coins? Head, 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 tail, tail, head, tail, tail. Are there any others? Did you guys do this in biology for boys and girls genetics? All right, so how many possibilities are there? 4. So when you toss a coin 2 times, or toss 2 coins, you know the denominator is going to be 4. So you look at this. What's the probability of getting 2 heads? 1 out of 4. What's the probability of getting 2 tails? 1 out of 4. What's the probability of getting 1 of each? 2 out of 4. What's the probability of getting head on the first and tail on the second? 1 out of 4. So if you can write out all the possibilities, it's so easy to get the probability. Okay, but what about tossing a coin 3 times now? Or having 3 children, for those of you who took genetics. Where do you learn genetics? Biology? In an AP biology for sure. So if you toss a coin 3 times, what's the sample space going to be? Okay, so what you want to do is you want to count them systematically. We did this in SAT prep too. You can get head, head, head. See, what I like to do, I like to go alphabetical order. There's only H and T, right? But you have some kind of system so you can catch them all. Next. H. Do I have to teach you how to alphabetize? Oh boy. Hey, Mr. Park, this reminds me of logic. Remember when we made the truth tables? What's a truth table? I want to cry right now. I taught you all I know. There. That's all 8 elements. Remember, except instead of H and T, we had true and false when we did logic. It's the same thing. Anyway, so when you toss a coin 3 times, how many elements are there in the sample space? 8. So the answer is going to be something out of 8. What's the probability of getting 3 tails? 1 out of 8. What's the probability of getting 2 tails and 1 head? So 2 tails and 1 head. 2 tails and 1 head. Right there, 3 out of 8. It's so simple if you can. But then now, what happens if I toss a coin 4 times? There's going to be 16 elements in the sample space. Do I really want to write them out? You can if you want. 16 is not that bad a number. But what if you toss a coin 10 times? You want to write out all 1,024? No. So then, okay, so what happens if you toss a coin 4 times? So you know the denominator is going to be 2 to the 4th, which is 16, right? You guys know why it's 2 to the 4th? Because the first coin, how many choices does it have? 2. It's either heads or tail. What about the second coin?
2.
2. Third coin, 2. Fourth coin, 2. 2 to the 4th, 16. So when you toss a coin 4 times, the denominator is going to be 16. What's the probability of getting 1 head? Okay, let's start easy. What's the probability of getting 4 heads, all heads? 1 out of 16. What's the probability of getting, what did we do first? 4, 3 heads.
1 8.
Wait, Mr. Park, I think I see a pattern.
1
No, wait. I think I see a pattern. Okay, look at this one right here. Okay, why don't we do all of them? This, also, nobody saw the pattern. I want to cry right now. Okay, what's the probability of getting 3 heads? What's the probability of getting 2 heads? 3 out of 8. What's the probability of just getting 1 head? 3 out of 8. What's the probability of getting 0 heads, which means all tails? Okay, what about this one? Let's do this one. Hopefully you guys see a pattern here. What's the probability of getting 2 heads? What's the probability of getting 1 head? What's the probability of getting no heads? Do we have to do this one? Do you guys see a pattern? Look, 1, 2, 1. 1, 3, 3, 1. Where did we see these numbers before? Pascal's triangle. We just did it last chapter too. It shows up all over. Okay, here's the 4th row of Pascal's triangle. So what do you think? What's the probability of getting, 3 heads? 1 out of 16. That's why if you add up all of these numbers in the 4th row of Pascal's triangle, if you add up all these numbers, you will get 2 to the 4th, which is the 16. That's all the possible cases. What's the probability of getting 2 heads? No. 3 heads, 2 heads. No. 4, we didn't write it out. What's the probability of getting 4 heads? 1 out of 16. What's the probability of getting 3 heads? 4 out of 16. What's the probability of getting 2 heads? 6 out of 16. What's the probability of getting, where am I now? 1 head. 4 out of 16. And what's the probability of getting no heads? 1 out of 16. And then you can just extend this as far as you want. So many of tonight's problems, if you just write out the sample space, it's so easy to do. But then again, when the numbers get bigger, you don't want to write out the sample space because it's going to take too long. Okay, now let's do another one. What about rolling a die? What if you guys know what a die is, right? Okay, if I roll a die, what's the probability of getting a 5? And again, you gotta assume it's a fair die unless I say so. What's the probability of rolling a 5? 1/6, right? Because each one is equally likely. They're all 1/6, right? Okay, but what about rolling 2 dice? Well, what can happen when you roll 2 dice? So everybody needs to see this at least once in your lifetime, okay? That's why I wrote it all out in the notes, yeah? You can get a 1 and a 1. You can get a 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6, 2 and a 1. Now, after you see this the first time and see the pattern, then no worries, mate. You know what we did in my calculus class on the video, because we had some people absent? Is anybody absent here? Oh yeah, Kusumoto. Well, we should do a dance for her. Anybody know a good dancing song? Okay, well, by the time I finish writing this up, somebody better come up with a good dancing song. Not 3, 2. Doesn't even make sense. 4, 2, 4, 3, 4, 4, 4, 5. I'll give you a hint, this is going to be on the first probability quiz, you know. So you either got to remember it, remember the pattern, because, I don't know, you probably don't want to write it all out, but it's really helpful. And finally, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. This is the sample space when you roll a die twice or 2 dice, it doesn't matter. How many elements are there? Really? 36, 6 times 6. Okay, so whenever you roll 2 dice, you know the denominator is going to be 36. What's the probability of rolling snake eyes? You guys know what snake eyes is? What? Snake eyes is a 1 and a 1. See how it's like eyes of a snake? That's snake eye. Okay, what's the probability of rolling a 2? 1 out of 36. What's the probability that the sum of the 2 numbers is a 3?
3 out of 36.
2 out of 36. What's the probability of rolling a 4? 3 out of 36. You starting to see the pattern? What's the probability of rolling a 5? 4 out of 36. What's the probability of rolling a 6? Yeehaw. 7, 8, 9, 10, 11, and then 12, which is back down to 1 out of 36. What's the most common roll then?
7.
This one right here, 7, because that's the highest probability. The probability of rolling a 7 is 6 out of 36. Yeah, you guys ever heard of the game craps, which is park backwards? Think about that for a second. Every time I say park backwards, they think carp. It's not carp. In fact, since we're at it, look, what is park backwards? See, now you get it. See, you have to actually see it there. And then my first name, Michael, look, you write that backwards. So if you do it like this, what am I doing? Lick'em crap. Okay, what? Did you guys come up with the song yet? Nobody knows a good dancing song?
Come on.
What? What?
Oh, nothing, never mind.
No, people?
I think it's too inappropriate.
Or Bruno Mars? Is anybody gonna play it so we can dance for the video?
No. No, play a song.
You guys don't have music on your. I got funny music on mine.
No.
But then the best music I have for dancing, I got Madonna. You guys like Madonna songs?
Yeah.
Okay. Come on, get him. Play something for me. Hurry up!
Let's go. Yes.
No, from your iPad. No, okay, do your phone then. Do your phone. Isn't it sync? You guys don't sync it. Why not?
We can't.
You can't. But you still can put music on it.
No.
You can't even put music on it. How come I can put music on mine? Yeah, we're not.
Come on, no.
Play Gummo.
Cool, come on. Yeah, make sure the lyrics are
Okay, never mind.
acceptable now.
Never mind.
Okay, come on, Chad. This is gonna be on video now. Administrators might be watching this.
See.
Again,
You said Bruno Mars?
Noah, again. Okay, what's that one done? Don't believe me, just watch. What's that called?
Uptown Funk.
Okay, do that on.
No, you're just singing too.
No. Dance now.
Sing it. Yeah. Yeah. Yeah, talk. No, you're gonna be right.
Okay, I'm done. Same thing happened in calculus class. I got gassed after 10 seconds. Woo!
That was cold.
Okay, now what happens if you roll 3 dice? Like, are we rolling 3 dice tonight? Yep, number 2. So, what happens if you roll 3 dice?
6.
How many elements are there going to be in the sample space?
6 cubed.
6 times 6 times 6. That's 216. Are we really going to write it out?
No.
No, that's craziness. So, we just and then we just count the numerator part. Okay, so we roll 3 dice. What's the probability that the numbers add up to?
2.
And don't be like last year. I remember one of the periods said 2. How you gonna get a 2? The smallest roll you can get is a 3, right? But see, this would be too easy for a quiz. What's the probability of getting a 3?
1.
1 out of 216, because the only way you can get a 3 is a 1, 1, 1, right? So let's do something more challenging. How about a 5 then? What's the probability? Okay, how many different ways can you get a 5? See, this is combinatorics now. See, we did combinatorics for the denominator, right? 6 times 6 times 6. Now we just gotta do it for the numerator. Okay, give me one case where you can get a 5.
1
1, 1,
3.
3. But how many different orders can you put them in? Do you want to list it all out, or do you want to do like alfalfa or Mississippi? How many 3-letter words can you make?
3 factorial over 2 factorial. 3.
3 factorial over 2 factorial, which is 3,
3.
right? Or just say the 3 could be here, here, or here, so that's 3. So this one is 3. What other ways can you get a 5?
1, 2, 3.
A 1, a 2, and a 2. How many different orders can you put them in though?
2.
Again, 3, and then? Is that it?
Yeah.
Yes, that's it. So the answer is 6 out of 216. Okay, that one was too easy. Let's kick it up a notch. Let's do the probability of getting a 7 then. How can you get a 7?
1.
1, 1,
5.
5. How many different orders though can you get?
3.
You get 3 different orders. Right? Because you guys know the order is important, right?
Yeah.
There's a first roll, a second roll, and a third roll. That's all. All right, what about 1, 2, 4? How many different orders?
6.
6, right? 3 factorial, right? Alfredo, Bernardo, Carlos. 3 factorial. 6. 1, 3, 3. How many different orders are there? 3. 1, 4, 2. We already got that one. So now we go 2. 2, 2, 2, 2, 3. How many different orders? 2, 4, 1. So we can't do that. So 3, 3, 3, 1. We already got it. So that's it right there. We got them all. So what's the answer?
8.
Hey?
15.
15 out of 216. See, so after a while, you don't want to write out the sample space because it just takes too long. So then you know how many in the sample space, and then you just count how many in the numerator then. Okay, let's do another one. Number 6. Let's do number 6, a problem like number 6. And good enough, I'm not going to tell you how to do that. Oh, we already did the coin one over there. Okay, a number between 100 and 999 inclusive is randomly chosen. Okay, so what's the denominator going to be? How many numbers are there between 100 and 999? We talked about this last chapter. 900. How do you know? Oh boy. How many numbers are there from here to here? What do you do? Just subtract them? No, you subtract and you add 1. This is on the SAT. SAT cheat sheet, it's right there. By the way, you guys are taking SAT this Saturday? You guys gonna actually look at that cheat sheet? I spent half my career making that. Or you could use the multiplication principle. How many choices do I have for the first digit? Anything except the 0. 9, and then now you can use the 0. Now use the 0 multiplying at 900. It doesn't matter how you get it. Okay, now it says, find the probability that it contains no 7s. How many 3-digit numbers contain no 7s? We did that. We did that problem. Okay, do you really want to count it out then?
No.
Okay, so let's do this then. Okay, 3-digit number. How many choices do I have if it doesn't have a 7? 8. And then now you can use the 0.
9.
9 and 9. You just can't have a 7. Multiply that out. What is 80? What is 998? 81 times 8. 648. Is that right? 81 times 8. Yes, it is. So the probability that a number contains no 7s is 648 over this. Of course, you can reduce it, right? I'm not going to reduce it. I'm just showing you how to do the problem. Okay, and then, what's the probability of getting at least 1 7? What did we do last chapter when you have the phrase at least 1?
Find out.
You do the complement, which is no 7s, and you subtract it from the total. But when you're doing probability, so this is the probability of getting what? No 7s. So what's the probability of getting at least 1 7? You subtract it from, this is probability now.
Denominator.
1. 1 is the total for probability, right? 1 is the probability of everything happening. So you compute the probability of the complement and subtract it from 1. That's a lot faster. Because you guys remember why at least 1 7, it takes too long, because what does at least 1 7 mean? 1, 2, or 3. You're going to do the 3 cases, but in each case, there's different cases as well. So that's why when you see the phrase at least 1, you got to keep on doing it. I'm going to do the complement and subtract it from the total. So we're going to still use the same techniques we did. Number 8 is a geometry problem. Hopefully you guys remember some geometry. And don't look at the answer until you actually, try the problem. Oh, and there's a card problem there, number 3. But you're only drawing 1 card, so come on, it can't be that difficult. So tonight's homework easy, and then we're going to kick it up a notch next time, which is, we're not going to do it till Monday then, right? Yeah. Okay, any questions on this? Okay, we are done. Was it you yesterday that gave me the suggestion before the game? Was period 3 then? Because we played a game, what game did we play in your class, or we played 2 games?
What about countries? I like population and size.
Oh, okay, because period 3 said they played it already, so they said, Mr. Park, why don't you make a game, your favorite lunch places? Let's play it, so I made it. So these are all places where I actually eat lunch. Because I almost never bring home lunch. I want to drive somewhere and get it. So sometimes I get it on the way to school, but most of the time it's going to be around here. And I love fast food, I'll just tell you that. So these are not expensive lunches by any means. Okay, who won yesterday's game?
Both.
Girls? Boys? Actually, we should turn off the video because then other classes are gonna watch it. But then we're gonna play it today, so just leave it on. Okay, so boys go first. Okay, this is a top 42 list. So these are all the places like from my mind where I've gone at least several times. Okay, these are my favorite. Okay, boys. Taco Bell. 15.
No.
If it's not on the list, you get 50. Girls.
Popeyes.
Popeyes. 7.
No, you a dummy.
I must talk about it in class sometimes, right?
Yeah.
10.
McDonald's.
McDonald's. 4. Girls.
Jack in the Box.
Jack in the Box. 27.
Zippies.
Zippies. 10. In fact, my lunch today, you see the lunch in the back of the package? It's high on the list here. You guys recognize that package?
Turn the sheet.
By the printer. No, you probably don't. Okay, girls, who's the next girl? Right here? Liu. Most of them are right around here. Or just name any fast food restaurant, it's probably here. Biology. 17. My love of pizza. Boys. Burger King. 34. Plus, the farther away it is from school, then the probability is less I go there. It's not that far. Girls?
Pizza Hut.
Pizza Hut. 19. Boys? Rainbow Drive-In. Should be kind of upper half, I would think. Here it is, 23. Girls. Who? Oh, Raising Cane's. 12. Boys.
California Pizza Hut kitchen.
Okay, that's not on the list. That's too expensive for me. I'm only a teacher, you know. Girls. Plus, gotta go Ala Moana or gotta go Kahala Mall for that one. Okay, girls.
Costco.
Costco. 14. I would drive to did I tell you I used to drive to, I didn't do it this year, to the Hawaii Kai Costco just to get a hot dog, a drink, and a slice of pizza. It's a good lunch, man. Okay, boys.
Subway.
Subway. I just went there yesterday. Subway, 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 Subway. Oh, how come it's so low? 35. If I were to revise it, it would be higher, but too bad you got 35 points. Girls. Arby's, number 1. Boys.
Wendy's.
Wendy's. Wendy's. Where is it? How come I'm not seeing it? Okay, well, I'm just gonna, this is what it should be. Wendy's would be somewhere around Taco Bell. 16 then. 187, and then finally, girls,
Foodland.
Foodland. What do I like to get for food at 32? Poke bowl? Sometimes, but then usually, you guys ever eat the salt and vinegar chicken? Oh yeah, it's good. Okay, that's it. Here, I'll just tell you my top 10 because maybe we can use. No, I shouldn't tell you, yeah? Okay, no, can't do it again. Number 2, Grace's Inn. You ever been there? Baratang Street. Number 3, Gulick Delicatessen. That's where I went this morning. You guys ever been there? No. Number 5, Earl Kaimaki. Sandwiches? Earl Kaimaki, no. Number 6, Charlie's Sub. Alawana, Charlie's Subs. Good French fries. Number 8, Mitsuken Bento. Garlic chicken, super good. Number 9, Sugoi's garlic chicken, super good. Number 10, Zippy's, okay. No, just 11, Char Hansa. Maybe you guys don't even know it, so you guys can go. You guys ever heard they make Manapur, pork hash? No. AJA at Alamoana, Bento. No. The Chunwa Cam by Alamoana. Baked Manapur, good. Jersey Mike's by Raising Cane's down there. Lahaina Chicken, Alamoana. No. Boston Pizza by Kamaki. Kahai Street Kitchen. No. Never mind, you guys don't even know these. Sabaro Pizza. Sumo Ramen. KFC. Panda Express, Burger King, Subway, Safeway. Gina's, L&L, Jollibee. You guys ever had Papa Kurt's hamburger? It just opened over there, across Stadium Park, no? What about Chubby's Burgers? No. Anyway, that's there like 40, 41, and 42, the last on the list, on Chinese food. Kapahulu Avenue, on. Turn off the video. Okay, we're done. The bell will ring in 6 minutes. No. What am I talking about? 8 minutes.